Hello and welcome back. The fourth item that we need to study whenever we get an NMR spectrum, it will be shape of each signal. So you looked at one specific signal and you will ask yourself like, is there any splitting? And do I see fine or small, peaks attached to it? And that one is going to give you huge info about neighbor atoms and like how many hydrogen atoms are attached to the neighbor carbon atom. And if we have like, let's say in a singlet, just one sharp peak, in that case, we say there is no hydrogen atom attached to neighbor carbons. But if I see two peaks, so let's say with our signal got to split into two peaks, in that case, I'm going to say the neighbor carbon has only one hydrogen. So here, no hydrogen. This one is a triplet. That means we got the neighbor with two hydrogen. And now we got quarter. That means we have a neighbor with technically CH3. And how about the quintet? Quintet, clearly we can't have more than 3 hydrogen. And how do we get the quintet? We must have two groups, two CH, two groups that they are identical and they can split one hydrogen to 5 peaks. Now, how do we get the multiplicity and why do we get that in splitting? The reason behind it, imagine you have one hydrogen and the hydrogen that we're studying is HA. And it has a neighbor carbon. That neighbor carbon is carrying one hydrogen atom. The HB atom, it has a it has a spin. The state it has some spin, so it's going to be active in NMR. Now, spin of that state, it can be aligned with the magnetic field or against the magnetic field. So the HA hydrogen, effective magnetic field that HA is going to sense will be equal to B0 minus the magnetic field of the HB, because it's the opposite of the external magnetic field. But for the second one, for this one, because it's aligned with it, the effective magnetic field, it will be 0 plus BHB. So this time, because it's aligned with it, the magnetic field, it will be bigger. Okay, so what does it mean? It means that splitting the gap between alpha and beta, in this case, is going to be bigger versus the first one, which gave us smaller gap between the two states, alpha and again the beta states. And that's the reason we get 2 peaks. Okay, let's call this one delta E1 and that one we're going to call it delta E2. So which one of them represent delta E2? The one that has higher ppm or higher chemical shift. And that peak, the one on the left side, it will be delta E2, and the one on the right side, it will be delta E1. Because the one on the right side, when I say the right side, I'm talking about this tiny peak. Okay, that represents this delta E. Because it's shielded, nucleus. Because it's shielded, the nucleus is not going to feel a huge amount of magnetic field, so the gap is a small one. Okay, how do I figure number of peaks? There is an easy way to figure number of peaks, and we use this formula, n minus 1. Okay, and what's the n? Number of equivalent hydrogen. Okay, so if you know number of equivalent hydrogen, just simply add it to 1, and that's going to give you number of peaks that you number of technically splitting that you should get. Okay, now if hydrogen atoms are, we call them geminal. And what does it mean? That means they are sitting on the same carbon, and it happens that they are either homotopic or enantiotopic. In that case, they will be chemically they will be the same, and because they will be the same, they will not split each other. So no splitting if they are chemically equal. Be careful. Now, so when do we get this HA to split the HB or opposite? Whenever they are diastereo. If there is a second, chiral center, then yes, this is possible. How about in 2 neighbor hydrogen? They will split each other. And what if they are, more than 3 bonds far from each other? It's going to get weaker and weaker. Again, use this formula to figure out number of peaks that you should get whenever there's a neighbor hydrogen atom. Okay, so let's practice one example. We have a compound that is C7H6O. That compound is saturated. And because the H in the HDI is equal to 0, so I'm going to say no pi bond or a ring. Okay, so my compound is completely saturated. Now, they gave me the areas. I divide them by the smallest one, and I got 1 hydrogen, 6 hydrogen, and 9 hydrogen. Now, one of them, the one I'm going to highlight, is a broad peak. What does it mean? That broad peak is going to be an OH peak. Okay, because it's really acidic, and then like the bond, it's getting bigger and smaller all the time, and that's the reason we get a broad peak for it. So I know I have 1 hydrogen and sitting in oxygen, and that one is going to be the reference. Now, okay, compared to this hydrogen, we got one area it has 6, and the second one 9 hydrogen. The one that it has 9 hydrogen, there is high chance that is a methyl group Okay, and I might have 3 of them. Okay, and the next one is this one. It is showing me 6 hydrogen, so I can say either like it's another version of hydromethyl group or maybe CH2. So let's see. Okay, so I'm going to say, for now, let's close our eyes on number of hydrogen atoms. Just simply focus on the splitting. Okay, splitting, it says this one got split to 3 peaks. So I have a group that is neighbor to CH2. Okay, and it might be a methyl. Okay, it might be a methyl. Okay, that's got split to 3 peaks. And the reason for it, because we are saying n minus 1. If we have CH2, 2 plus 1. 2 plus 1, that's going to give me 3 peaks. Okay, how about this area? That one got split to 4 peaks. So I'm going to say it might be CH2 that is neighbor with CH3. Okay, so it's a CH2 that's neighbor to CH3. Okay, so we have a neighbor. How many neighbors? We have 3 hydrogens plus 1. That's going to give us 4. So it's going to be a quartet. And here you go. I see a quartet. Now let's talk about the area. One is 6 and next one is 9. What's the possibility? Can I have 3 from CH2? 3 multiply 2, it will give me 6 hydrogen. Yes. Can I have 2 from CH3 maybe? Yes. That's also 2 will give us 6 hydrogen. And how about next one? Can I have 3 from CH3? Yes, that's going to give us 9 hydrogen. So question is, which one of this I have? Do I have 2 different methyl groups, or I have 3 CH2 and also I have methyl group? Okay, I drew the possible structures, and as you see, integration in both cases will be the same. The only difference between them, it will be the multiplicity. Okay, I'm going to highlight the identical hydrogen or methyls. Those are identical. Also, these 3 methyls are identical. Same story here. CH2 are identicals, and the methyls are identicals. So what should I get for the multiplicity? Okay, now I'm going to say those hydrogens, they are neighbor to methyl. So I should see a quarter. Okay, and how about the methyl? The methyl, I should see a triplet. Okay, so quartet and triplet. I should write it with lowercase q. And how about the second molecule? The second molecule and the methyls are identical. And look for the neighbor. Neighbor has no hydrogen on it. So what do we see here? We see singlet peak. And how about this methyl, yellow methyls? Also, we will see singlet. So I see 2 peaks that they are singlet. And how about OH? OH will not get split. It will be singlet. And in both cases, it will be singlet. So what do we get here? 1 peak that is singlet. Second peak is a quartet. And next one is a triplet. And how about here? Singlet, singlet, singlet. And now I go back to the pattern that I have. I have 1 singlet. That's true. And next I have 1 triplet and 1 quartet. And that's matching the first structure. So I see singlet, put in the quartet, and triplet. And so I'm going to say the one on the left is the correct answer. Another example. Okay, let's match each structure to the data that's given. Okay, the first molecule. Okay, the second molecule, I can chop it to half. That means I have mirror. Okay, I see. I'm gonna say I have 1 CH3 here, 1 peak there, and 1 here. That's gonna give me 2 signal. Okay, 2 signals. That's it. And because it says just 2 signal, that's gonna be the correct answer for it. Okay, next, and this one has 1, 2, 3, 4. Okay, so I see 4 signal. How about here? 1, 2, 3, 4 signals. Okay, so 4 signals. That one also is going to give us 4 signals. Okay, now I need to differentiate them between 2 and 3. Okay, now let's highlight the methyl group. Okay, this methyl groups is neighbor to CH2. So the methyl groups Okay, it will be split to triplets, and I'm going to have a signal that represents 3 hydrogen. Okay, so wherever you have 3 hydrogen should be split to triplet. Okay, 3 hydrogen is double. Well, this one, 3 hydrogen, is a triplet. So I found structure of A. Structure of A should be the third one. Okay, so this one will be A. Okay, now how about this hydrogen, this methyl? Okay, let's go after this methyl. I'm going to highlight it with different color. Okay, now let's check the neighbor. Neighbor, it has only 1 hydrogen, and that's going to split methyl to double. N plus 1, we have 1 plus 1, that's going to be doublet. So we will have a signal doublet for 3 hydrogen, and that's going to be B. Okay, now